Good morning to one and all present here. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. Today we are discussing about understanding SQL Transaction Guide. This is for agenda. The introduction to SQL transaction and ACID properties in SQL transaction and starting a transaction and commit and rollback and save points and isolation levels in SQL and explicit implicit transactions and concurrency control in SQL transaction and error handling in transaction, example of SQL transaction and best practice for SQL transaction and conclusion. First we are discuss about what is the introduction to SQL transaction. First of all, what is SQL transaction? The SQL transaction is sequential of these operations and executed of a single logical unit of work. The SQL it is committed of all the operation executed and single unit known as the SQL transaction. And they are two type. One is data integrity and reliability. And data integrity, it is nothing but it is a ACID properties. It is a safeguarding for this corruption and by the inconsistency. Suppose we want some of the data transaction time, some of the inconsistency is very important. So safeguard the ACID properties based on this safeguarding from this corruption time, easily we can retrieve the data information. So we are using to the data integrity. And what is the enhancing reliability? And the reliability is it is a database operation through the rollback mechanism during a failure or errors. And what is the ACID in SQL transaction? Already we have discussed about what is the atomicity and consistency and isolation. The atomicity is known as ensure all the operation within the transactions time, and consistency it is called as valid of state one to another. Easily we can valid user or non-valid user, easily we can indication for this consistency. And isolation is guarantees the concurrent transaction and execution do not inference and maintaining for accuracy and reliability. Next one is what is the starting transaction, and the starting transaction it is initiating from this commands we have using the begin transaction or start transaction for the clarity. And example of begin transaction is we are using to SQL queries insert into the table and the table name and columns, and some of the value we are insert into the some value. That is a main example for this transaction. And committing changes, it is transaction time. The commit is one of the rule. So we are using to the query as commit, ensure all the data changes easily we can saved. So this using to committing changes. And commit and rollback, they are a function of commit and function of rollback and example scenarios. And commit is finalize the changes in your transaction, ensuring they are permanently applied to the databases. And the function of rollback, it is unto the changes during the transaction and restoring the database to its previous state. And example scenarios for this where unsuccessful processing requires the rollback and successful update instead of we are using to save the data in commit. Next one is save points. The save points, it is create the intermediate checkpoints within a transaction, and it is without affecting the entire transaction. So that it is mainly targeted from entire transaction, no affecting from the saving point is very important of this SQL transaction. And what is the usage of in transaction? And save points is greater control permitting the user unto the specific operation selectively within the ongoing transactions. The practical examples of after inserting the multiple records at the same time, some of the save points are rewards of the specified weekend changes. So it is an example. And isolation level in SQL, isolation level overview of how transaction visibility of manage the database system, and read uncommitted, which means it is changes from all other transaction, increasing the concurrency but risking the dirty reads, and repeatable and read and serializable. The repeatable and the repeatable reads. The serializable is ensure the complete isolation of preventing the platinum reads together. Next one is what is the implicit and explicit of transaction. And the explicit transaction is user defined and allowing fine tune the over the sequence of SQL operations. And the implicit transaction is explained. The implicit is transaction automatically commit changes after each individual statement, and simplifying the transaction management for user and use cases for each type. Explicit transactions are ideal of complex operation, while implicit is once shoot simple and the single statement of actions. Next one is concurrency control in SQL transaction. Concurrency management techniques like locking strategy maintain the data integrity during concurrent transaction execution. Locking strategies, different locking types such as shared exclusive locks prevent the conflicts in simultaneous database access, and the impact of isolation levels is significantly affecting the how transactions read and write the data from overall database operations. And error handling transaction is try and catch blocks. Try and catch block is some error trapping system. So easy to the mechanism is managed to exception systematically how to handle the transaction during. So error handling techniques, we are using the logging and alerting some transaction type, the error overall error management system, and best practice for using the transaction is scope clear rollback pathways and error enhance error resilience. And SQL transaction, they are using real world transaction example, typical banking transfer system. Easily we can accounting, crediting and debiting system, easily we can transaction from single transaction. So e-commerce order processing is nothing but is updating inventory and recording sales and managing customer order details together. And multi-step data entry like data entry for user registration and may involve the several queries being committed only if all the succeed. The best practice transaction performance and resource management strategies and ensuring the maximum database reliability. Those are conclusion. The best role of the critical role of transaction and ACID principles adherence and long-term data stability. And critical role of transaction is data consistency is maintaining accuracy of reliability during operations, and ACID principles of essential for ensuring the data transaction integrity and test in the database system. And the long-term data stability is ultimately support the long-term data stability, the minimizing the corruption risk and enhancing the reliability. Thank you.